This next unit is about systems of equations. Systems of equations is a set of two or more equations that have the same set of variables. A solution to a system of equation is a set of values for variables that make all of the equations in the system true. There are three different types of classifications of systems of equations. The first type is called an independent system. An independent system has one solution and the lines intersect at one point. You can tell if a system is an independent system if the slopes of the line are different. The second type is an inconsistent system. Inconsistent systems have no solution and no intersection points. These types of systems are parallel lines, which mean they have the same slope but different y-intercepts. The third type of system is called a dependent system. You can tell when a system is dependent if the solution is the same line. So that means when you have two lines, they have the same slope and the same y-intercept. There are three different ways to solve a system of equations. The first way to solve a system of equation is by graphing the two lines. In order to solve this system, first thing we need to do is to get our lines into slope-intercept form so we can graph them. In order to get them into slope-intercept form, you have to solve for y. For both lines. Now that I have slope-intercept form for both of my lines, I'm going to graph them one at a time. I'm going to start with y equals 3 over 2x plus 4. My y-intercept is 4, and my slope is 3 over 2. I'm going to put a few points on my line. And the second line is y equals negative 1/2 x minus 4. Y-intercept is negative 4, and I'm going to go down 1 over 2. The solution to a system of equations is the values for the variables that make both equations true. So in this situation, where the lines cross is the solution to the system. The lines cross at negative 4, negative 2. Finally, we have to check our answer. So we check our answer by plugging in negative 4, negative 2 into both equations. So wherever I see an x, I'm going to plug in negative 4. Wherever I see a y, I'm going to plug in negative 2. And you will know if you are correct if both equations work. It has to work in both equations, otherwise it is not the solution to a system. So it works in the first one. And the second one is also true. You write your final answer as a coordinate point. So the solution to the system is negative 4, negative 2. The next method is called the substitution method. The first step to this method is to isolate one of the variables in one of the equations. So I'm going to take a look at 3x plus 4y equals 12, 2x plus y equals 10. The easiest variable to isolate would be the y in the second equation. The only thing I would have to do to isolate the y in the second equation would be to subtract 2x from both sides. The reason why I do this is so I can make a substitution into the second equation. You see how I have y's on both sides in both equations? What I'm going to do is I'm going to take this negative 2x plus 10 and I'm going to replace it where the y is. The reason I do this is so I can have only x's left in the equation. And when I have only x's left, I can solve for x. The x value that I solved for is 5.6. What I'm going to do with this 5.6 is I'm going to use it to find my y value. So I'm going to plug the 5.6 into the second equation to calculate the y value. (11.2) plus y equals 10. Subtract 11.2 from both sides, y equals negative 1.2. The final step, like always, is to check your answer. We used this equation, the second one, to find our value, so we're going to have to check our answer, 5.6, negative 1.2, in the first equation to make sure that it is also true for 3x plus 4y equals 12. (16.8) minus 4.8 equals 12. This is also true. If you check your answer and it doesn't work, go back and check your work, see if you can find your mistake, because a false check tells you that your answer does not work in both equations. Don't forget to write your solution as a coordinate point. The solution to this system is 5.6, comma, negative 1.2. The final method is called the elimination method. The word eliminate means to cancel out. So we are going to use some algebra tricks to cancel out one of our variables so we can solve for the other. The first step to this equation is to multiply the top equation by 3 and the bottom equation by negative 2. So we're going to end up with 6x plus 21y equals 12, and negative 6x minus 10y equals positive 10. So again, multiply everything in the first equation by 3 and everything in the second equation by negative 2. The reason why we did this is now if we add our equations together, negative 6 and 6, they're going to cancel out. They're gone. Now we're left with 11y equals 22. Divide by 11, y equals 2. We're going to take that y equals 2 and we're going to plug it into the first equation. in order to find our x value for our coordinate. 2x plus 14 equals 4. 2x equals negative 10. X equals negative 5. So we have our coordinate point, negative 5, 2, and all we have to do is check our answer to make sure we are correct. We used the first equation to find our point, so we already know it works there. So we're going to plug in negative 5, comma 2 into the second equation. To make sure it works here as well. And again, your solution has got to work in both equations. If it doesn't work in both equations, you made a mistake somewhere. Works in the second equation. The solution to this system of equations is negative 5, comma 2.